So guys, today we will be solving convert one-dimensional array into the two-dimensional array. So from one dimension to a matrix two-dimensional array. The problem statement is pretty straightforward. It just describes the process of the conversion. I think it's better to go through an example. But first, for the input, we are given only like one-dimensional integer array called original, and two integers n and n, which represent our dimensions of the two-dimensional array. So we have to create m rows and n columns two-dimensional array that contains all the elements from the original. If you go to an example, you can see that we have m equals to 2 and n equals to 2. So we have 2 by 2 two-dimensional array. And the original array is given as 1, 2, 3, 4. So as you can see, the first two numbers will get placed in the first row of the two-dimensional array, while the last two numbers will be placed in the second row. If you had more elements here, they would just go underneath the second row to the third row. So you would have 5 or 6 or something. The constraints are pretty standard. Nothing special, nothing to worry about. The desired time complexity solving is obviously linear, because we are just expected to move through traverse to the original array and create a two-dimensional array. Also, we are expected not to use any additional data structure except for the result, which is our two-dimensional array. So to figure out how are we gonna transform one-dimensional array to the second two-dimensional array, let's just go to an example. This is the example from the problem statement. And as we can see, the first number will go to the first column, first row in the second two-dimensional array. So we'll place it here. The second number in the array will go to the first row, but second column of the two-dimensional array. Now we have filled our first row of the two-dimensional array because m is equal to 2 and n is equal to 2. And we are continuing with the second row. Now we are filling the second row with the third number from the original array. So second row and the first column. And the last number in the input array will just go to the second row, second column. So how do we know when to go? The problem is basically determining the position of each element in the input array. Where should we place it in the two-dimensional array? So the first question is, how do we determine the row? And so basically we are given n, which is the number of columns that we have. The number of columns that we'll have in two-dimensional array. And what is the number of columns? The number of columns, as you can see, is just the length. It's the length of each of the rows. So we know that the number of columns, which is n, will be the length of each of the rows. So how can we know that a certain element should fit in the two-dimensional array? So for example, if we have iterator over if you're traversing the input array and we have the iterator over the third number, we already know that we have filled the whole first row. But how do we know that? We know that because we are at the second number and the third number, and we have already passed through other two numbers, which is the number of columns. So we fill the first row, so we have to go down. In other words, if we divide the current iterator, the current index, with the number of columns, we should know which row we are at. So, for example, if we are at second element, it will be 1 divided, and this is integer division, and divided by 2, and this is 0. So we know that we still have place in the first row. But if we divide 2, if we are at the third element, and if we divide the index by 2, we know that here we have passed the first row. The first row is full, so we have to go down, and 2 divided by 2 is 1. The same goes for number 3. In the array, the index 3, if we divide, we will get 1. So the row is given basically by the current index divided by n. Now, how do we figure the column? The column, once the element is placed in the correct row, the column should be determined by the remainder of the space, like how much space, how many cells do we have in the row that we selected. So, for example, if we have the third number, we know that we are just starting to fill the second row. But if we have the fourth number in the array, we know that we already have filled a part of the array. So the remainder should immediately hint you to the modulo operator, which, for example, if we have 5 modulo 2, that will be 1, because 5 divided by 2 is 2, and then you have 2 times 2 is 4, and then 5 minus 4 is 1. So that's the remainder of the division. And so in that case, if we divide the current index 2, if we get actually the modulo of the current index 2 with the number of columns that we can place, the selected the current index, the element at the current index, which in this case is 2, so we will have 2 modulo of 2, which is 0. So that will be our column. But if you do that with the next index, we have 3 modulo of 2, and that in that case we will have remainder of 1. So we know that the free space that we have starts from 1, like the first element has already been filled. So, for example, if you in that case, if you had, let's say, n equal to 3, like 3 columns, and you had index, let's say 5, you would have 5 modulo of 3, and let's say that would be 2. So it would be the third column, and that you will place that number. Yeah. So the final formula is that we can get the row by dividing the current index by number of columns, and then to determine the column, we will just get the modulo of the current index and the number of columns. So basically, that solves our whole problem. Put up the solution. First, we will check if we can form the 2-dimensional array once we are given the dimensions m and n. To do that, we will just check if the product of dimension is equal to the length of the array. If it's not, we will just return an empty 2-dimensional array. And if we have the right dimensions, we will just create our result, which will be our 2-dimensional array with dimensions m and n. And then we will traverse through the original array with a plain for loop, each time getting the row and column by the forward that we determined using the example from the problem statement, and then using that row and column to insert the element at the current index. Finally, we will just return the result. And that leads us to linear time complexity with constant space complexity, because besides the result, we are not creating any additional data structures.